Number 2 asked, what is hydrogenation? Okay, so let me just write down the definition of hydrogenation. It is pretty much the addition of molecular hydrogen. So what they mean by molecular hydrogen is that it is an H2 form. So you're adding molecular hydrogen across a double or even a triple bond. And this takes place in presence of a metal catalyst. So some examples of metal catalysts can include like the platinum or palladium metal catalysts. Okay, so I'm just going to write down an example of the typical reaction scheme for a hydrogenation reaction. So these R groups can be any carbon group, and I'll just denote it as R, R2, R3, and R4. And you'll notice that they're all contain a double bond. And then I will be adding my molecular hydrogen and a catalyst. And let me just circle. So these are the two new hydrogens that are added onto the group. And then I'll just show that the double bond is reduced to a single bond. And then the rest of the R groups just remain the same. Okay, so let's see what the junior tutor said. Catalytic hydrogenation is the addition of molecular hydrogen, H2, across a double bond in the presence of a metal catalyst. The net result of this reaction is the reduction of the double bond to a single bond. That is the formation of an alkane from an alkene. So the reaction is illustrated below. This reaction would also occur in alkynes. Note that for alkynes, 2 moles of molecular hydrogen are needed to produce an alkane. There are some considerations to be made depending on the catalyst used. That is, there is a possibility of producing 2 isomers from one alkene. For example, 1-methyl-cyclopent-1-ene can produce 2 enantiomeric products after catalytic hydrolysis. So here's an example of how you can get both the syn form of the product and the anti. So what they mean by syn is that you'll notice that the 2 hydrogens that were added are on the same side. So it's shown here with the solid wedge. And if it was in the anti configuration, one of the hydrogens is in the solid wedge, and the other one is in the dashed wedge. So they also explain whether the product would be the syn adduct, where the hydrogen atoms add to the same face of the alkene, or the anti-adduct, where the hydrogen atoms add to opposite faces of the alkene. Depends on the catalyst used. Yep, so that was a great answer. So this solution is correct. Yeah, that was Good answer.